In this video, we are trying to discuss about the topics, does changing weights change solutions too? And we focus our discussion on two particular graph theory problems that are the minimal spanning tree problem and the minimal cost ST-path problems. And the description is follows. For each of the following two statements, decide whether it is true or false. If it is true, give a short explanation, and if it is false, give a counterexample. A. Suppose we are given an instance of the minimal spanning tree problem on the graph G with edge costs that are all positive and distinct, and let T be a minimal spanning tree for this instance. Now suppose we replace each edge cost C by its square, C squared, thereby creating a new instance of the problem with the same graph but different costs. True or false? G must still be a minimal spanning tree for this new instance. B. Suppose we are given an instance of the shortest ST-path problem on a directed graph G. We assume that all edge costs are positive and distinct. Let P be a minimal cost ST-path for this instance. Now suppose we replace each edge cost C by its square, C squared, thereby creating a new instance of the problem with the same graph but different costs. True or false? P must still be a minimal cost ST-path for this new instance. So for the minimal spanning tree question, we will say that the answer is true because for all well-known algorithms for calculating a minimal spanning tree problems given a weighted graph, if we change the edge cost from C to C squared for each particular edge, the selection procedure run by every algorithms does not change at all. So T must still be a minimal spanning tree for this new instance. And for the minimal cost ST-path problems, we have some counterexamples that provided to you. Suppose we are given a ST-path with two paths. For example, we have S to A with cost 1, and from A to T with cost 4. And we have another path which is also a minimal cost ST path, which starts from S to B with cost 2 and starts from cost B to T with cost 3. Now we know that both paths have cost 5 is the minimal shortest ST minimal shortest ST path problem starting from S to T. And if we replace the edge cost for the whole graph, which means that the cost starting from S to A with the cost 1 now becomes cost 1, and from A to T now becomes 16, and the cost from S to B becomes 4, and the cost from B to T becomes 9. Now the first path, if we choose the total cost for the first path is 17. Now after replace each edge cost C by its square C squared. So if we suppose that the P will no longer be which is also the shortest because we can find an even shorter path with the directed graph G 13. Then which means that no longer be the shortest path given anymore because